Imagine for a moment an empty box, nothing inside, no particles, no air, no light, not even a single atom. You might think this is the purest definition of nothingness, a void, a perfect absence. But quantum physics whispers a shocking secret, that nothing is not nothing at all. Beneath the surface of emptiness, reality is boiling with invisible energy, an ocean of restless activity. This is zero-point energy, the most fundamental and mysterious background to existence itself. And the more we uncover about it, the more disturbing, exhilarating, and reality-shaking it becomes. Because if this energy can be tapped, it could revolutionize technology beyond imagination. Or if it slips out of balance, it could rip apart the very universe. We grow up imagining a vacuum as empty space. Remove all the matter, and what remains should be sheer nothingness. But quantum mechanics destroys this classical picture. According to the Heisenberg uncertainty principle, you can never simultaneously pin down a particle's position and momentum with absolute precision. At the deepest level, uncertainty rules everything, and uncertainty doesn't stop at particles. It seeps into the very fabric of space-time itself. Even in a perfect vacuum where no particles exist, quantum fields still fluctuate. Tiny bursts of energy flicker in and out of existence. It's as if nothing is alive, always trembling, always restless. This irreducible baseline of jitter is what we call zero-point energy, the lowest possible energy state of the universe. Even if you cooled everything to absolute zero, space itself would still hum with energy. But how does this vacuum energy reveal itself? Through the strange antics of what physicists call virtual particles. Imagine, out of the emptiness, a pair of particles suddenly pops into existence. A particle and its antiparticle. They appear, exist for a fleeting instant, and then annihilate each other, disappearing back into the void. This bizarre event is allowed because the energy they borrow is paid back so quickly that it doesn't break the cosmic accounting rules. It's as if the universe runs on a credit system, borrowing energy for a fraction of a second, then erasing the debt before anyone notices. These ephemeral particles aren't directly observable, yet their fingerprints are everywhere. They subtly alter the behavior of electrons in atoms. They shift the energy levels of hydrogen, creating the famous Lamb shift, confirmed by experiments. They even cause a real measurable force between two metal plates placed close together in a vacuum, a strange attraction called the Casimir effect. In other words, this empty nothingness can push objects around in the real world. Nothing is not nothing. Nothing is something. Physicists now see zero-point energy as the foundation of the quantum fields that fill all of space. Every kind of particle, electrons, photons, quarks, arises from a corresponding field. And even when no particles are present, these fields are never at rest. They vibrate, fluctuate, and seethe with latent energy. Imagine the universe as an ocean. The waves and splashes on the surface are the particles we observe. But beneath, the ocean itself is always in motion, a restless, deep undercurrent. This sea of zero-point energy exists everywhere, at every point in space, at every moment. You are bathing in it right now. Every breath you take, every atom in your body, floats on this invisible tide. The implications are staggering. Zero-point energy may not just be a quirky footnote in physics textbooks. It could be the very thing driving the expansion of the universe. Astronomers discovered that the cosmos isn't just expanding, it's accelerating. Galaxies are rushing away from each other faster and faster. Some unseen force is pushing everything apart. The culprit? Many physicists suspect vacuum energy, zero-point energy on a cosmic scale. In this interpretation, empty space itself has a kind of built-in repulsion, stretching the universe like an inflating balloon. It's sometimes called dark energy, and it makes up around 70% of the universe. Think about that. The majority of the cosmos is dominated not by stars, planets, or galaxies, but by the energy of nothingness. But here's where things get bizarre. If you actually calculate the expected zero-point energy from quantum field theory, you get an answer so absurdly huge it defies comprehension. The math suggests the vacuum energy should be 10 to the power of 120 times larger than what we observe. That's a 1 followed by 120 zeros. The largest known mismatch between theory and observation in all of science. This is called the cosmological constant problem, the most embarrassing prediction in physics. It's as if the universe is hiding the true extent of its vacuum energy, balancing it out almost perfectly to allow stars, galaxies, and life to exist. Why? Nobody knows. Some say it's a cosmic coincidence. Others whisper about deeper principles of reality. And some dare to suggest that countless other universes exist, each with different amounts of vacuum energy. And we simply live in the one where conditions happen to allow us. The obvious next question is this: if zero-point energy pervades all of space, can we use it? If even a teaspoon of empty space contains more latent energy than all the oceans of Earth, could we harvest it for unlimited power? Science fiction loves this idea. Free, clean energy drawn from the vacuum itself, machines running forever, starships powered by the infinite void. In fact, some real scientists have wondered if clever engineering could exploit quantum fluctuations. The Casimir effect already proves the vacuum can exert measurable force. Could advanced technology amplify this? Skeptics argue that the energy is locked away, inaccessible. Nature's bookkeeping laws forbid us from drawing on it freely. But then again, history is full of once impossible feats, from flight to splitting the atom. If humanity ever cracks the code of zero-point energy, it would be nothing less than a second industrial revolution, one that rewrites civilization. But with promise comes peril. Zero-point energy may not just be a hidden resource. It may be the universe's ticking time bomb. Some physicists warn that our cosmos exists in a false vacuum, a precarious state of zero-point energy that isn't truly stable. Like a ball resting in a shallow dip on a hill, it could one day roll down into a deeper, more stable state. If that happens, the fabric of reality itself would change. The laws of physics, the constants of nature, even the structure of atoms would be rewritten, and the transition would spread at the speed of light, obliterating everything in its path. From our perspective, it would be instant annihilation. One moment, life; the next, nothing. This isn't fantasy, it's a real possibility derived from quantum field theory. The universe might not be eternal, it might just be borrowing time. And here's the paradox: zero-point energy doesn't just threaten to end the universe, it may have created it. Some cosmologists believe the Big Bang itself emerged from a quantum fluctuation in a vacuum. Out of nothing, a burst of zero-point energy created space, time, matter, and everything we know. In that view, emptiness is not absence but potential. The vacuum is pregnant with universes, each waiting to be born. This turns the very definition of nothing upside down. The void is not dead and inert. It is the most fertile ground imaginable, the womb of reality itself. So let's step back. We began with the idea of nothingness, a void, a vacuum. And we discovered that emptiness is alive with energy. It gives rise to virtual particles, pushes on objects, expands the universe, and may have birthed everything. It could one day destroy everything too. Zero-point energy is the background hum of existence, the ultimate paradox: invisible, yet undeniable; untouchable, yet omnipresent; meaningless, yet perhaps the most important thing in the cosmos. Next time you look up at the night sky, imagine the vast darkness between the stars. That blackness isn't empty, it's a storm of hidden energy, a restless sea of fluctuations older than time itself. You are not floating in nothingness, you are floating in a cosmic ocean of zero-point energy, and maybe, just maybe, one day humanity will learn to ride its tides, for better or for worse. Because in the end, the greatest secret of the universe may be this: nothing is not nothing, nothing is everything.